Yesterday in lesson 7.1, we did ABC. You guys just did DEF? Piece of cake? Do you remember what we're doing from yesterday? Maybe, maybe not. So let's review. On D, y equals 3 times 4 to the x. Is that an example of growth or decay?
Growth.
And how do I know growth?
It's bigger than 1.
What's bigger than 1?
The rate.
Okay, so the number in parentheses, the rate of change, the number raised to the x. Okay, so whatever your b value is bigger than 1. And if it's bigger than 1, that is, by all means, representative of an exponential growth problem. So it is exponential growth, I agree. What about the y-intercept? Y-intercept of? 3. And we know the y-intercept is 3 because that is my a value, right? A is the initial value, also known as the y-intercept. A is this value out front. And so in this case, my y-intercept is 3. I don't know if anyone started the Math Excel yet or not, but they want them in ordered pairs, don't they? I'm pretty sure they do. So when we give this as an ordered pair, we're going to say 0, 3 to make Math Excel happy. Okay? Yes?
Will we have to do any problems where the rate of change is a negative number?
Not in terms of this. And in fact, it can't be a negative. I don't.
Because I was just wondering, because if that b has to be bigger than 0 or less than 1 for it to be decay.
Right. When we're talking about growth and decay, that b value will always be positive. Yeah. Okay. E. Is E growth or decay?
Okay.
Decay, because 0.75 is a number between 0 and 1. And what is our y-intercept?
0.
Okay. Y-intercept is that a value out front, which is 11, as an ordered pair, 0, 11. I don't remember if this happens in homework or if I'm thinking if this is more for my pre-cal notes or something, but let me throw a what if at you. What if I just had 0.75 to the x and there was no number out front here?
It'll be 0, 0.
Not 0, 0. 0, 1. In other words, what would be the invisible number out here if there isn't a number out front? That would be a 1, yes? So just realize, because you can always say that's 1 times 0.75 to the x. You can't say 0. Common mistake, I get it. But it'd be 1 times 0.75 to the x. So just, if there's no a value, realize that a is 1. Okay. Yes?
So if b was a negative number, would it be a no solution?
It's not that it's no solution. It just doesn't fit into the growth and decay formula, so to speak. So that's why you wouldn't see a negative. I don't know that I want to call it no solution, but you just won't see a negative because it doesn't fit the growth decay idea. Well, yeah, no, unless the exponent's negative, so no. Okay, F. Did we do better on F than we did on C? You got to read it, yes, and think more in terms of what's going on here. $2,000 in a college savings account for 4 years. The account pays 6% interest. Is this growth or decay? Yeah, the account is paying the interest, right? So my money is growing. This is why you want to be able to put money in a savings account. Okay, this is growth. And then it asks for the y-intercept. What would my y-intercept be? 2,000, because the y-intercept is another name for the initial value. And your initial value, your starting amount here would be the 2,000. Did not write that as an ordered pair there. You would if you had to, though, right? Okay, we got an idea of difference between growth and decay. as we move to the next page here, we're going to be working with the equation now. And at the top of the next page, we have a basic equation that we're going to be working with. A of t equals a times 1 plus r raised to the power of t. Now, this is, in the examples we're working with today, at least at the beginning, interest, money. Okay, this is a common interest formula here. However, it can also talk about population or, in terms of like species, those type of things. There's various science ways we could associate this. What do you think that little a stands for out front? If you think back to the previous page of a times b to the x. Initial value. Okay, so I'm just going to kind of run through what each piece of this equation stands for. And that little a out front stands for the initial value. What about t? What's t always stand for? Time. So as per the normal, t is in terms of time. What about r?
Right.
The rate? I'm specifically going to say the percentage rate. But I agree, rate. Now, when we put a percent into an equation, what form of that percent do we use? Usually the decimal form, yes? So you wouldn't put 5% in, you would change it to a decimal. So when we talk about R, it is the percentage rate as a decimal. Okay, so the percent as a decimal. And then the other piece I kind of want to mention here is the A of t at the beginning. And the A of t at the beginning, officially it's the amount after time t. Probably a better way to put it is the balance. If we're thinking in terms of money, it's the balance after time t or at time t. So I'm going to say this is the balance or amount after t years. Just so you kind of know. Basically, for what we're doing at this level, A of t is usually what we're trying to find. We're usually trying to find the amount after blank number of years. A little information over there. Notice it says if R is positive, this represents exponential growth. In other words, if you have a growing situation, we are going to do 1 plus the R value. And if you recall from the front page, if it's bigger than 1, it's growth, right? And that's because you're doing 1 and you're adding the percent. So if R is positive, it's going to be growth. If it's a decay situation, then we're actually going to be subtracting the R value. And so if we're going to use a negative R in a decay situation. One other thing that they might throw at you in Math Excel, if they ask you for a growth or decay factor, the growth or decay factor refers to what's in the parentheses there, which is whatever 1 plus R is. This is your growth or decay factor, depending on the situation. So whatever is there in parentheses raised to the variable.
So that does not include the A.
It does not include the A, nor does it include the T. It's just the 1 plus R.
So does it include the exponent?
No.
Okay.
Nope, just the 1 plus R. Okay, before we move on to our first example, do you have a calculator at your desk? If not, get one. Take this opportunity to get one. You need a calculator at your desk because you need to know how to use the calculator to do this. Some of you know how to do this type of stuff on your calculator, some of you do not. So if we make sure we are all together on this, have a calculator at your desk so you can practice with me and you can make sure you're getting the same answer. You ready to try example 3? You invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? You would have to open a savings account with your parents. Like their name would have to be on it. I don't know if that's until age 18 or what age that is, but yeah, you can have an account some kids have accounts from the time they're born. So, okay. A gift maybe. Maybe mowing yards, earning, shoveling driveways. I don't know.
When I was born, I got $100 from my great grandpa.
When you were
There you go. Okay, now, notice. Did you guys catch? I already did step 1. What was step 1? I read it, yes? I'm trying to get that into you guys because some of you guys will just words, moving on. You can't do that, guys. Words are life here. You want to know how am I preparing you for real life? You can't just skip over words. You could be skipping over something important here, okay? So we have to read the problem. Now, we're going to go back and reread it and work on dissecting it here. Okay, we're going to break it up to pieces and see what we can find. So, first sentence. You invested $1,000 in a savings account at the end of 6th grade. What does that sentence tell me? Okay.
initial at the start of 6th grade.
Yep. Okay, so $1,000 is what I'm going to call my A value because I started with $1,000 and A represents my initial value. Okay. The account pays 5% annual interest.
Rate of change.
Okay. 5% is my rate of change, my R. Now, what form of 5% do I use? Okay. We need the decimal form, which says we move our decimal 2 places left, or divide by 100. And so we move it 2 places left, it is 0.05. While we're here, is this a growth or a decay situation?
Growth.
Growth, right? It's paying you interest. So I want to think about it while we're here. This is growth. And what's important about knowing that it's growth is that we are going to be adding that percentage rate, yes? If it was decaying, we would be subtracting that percentage rate. But because it's growing, we're going to be adding that percentage rate. Okay, final sentence. How much money will be in the account after 6 years? What's that tell me? T. T is the 6 years. I know you don't see the number 6, but you've read it in words, yes? Important reason to read here. Okay, guess what equation we're using? A of T equals A times 1 plus R to the power of T. So I've written my equation in, and now my job is to fill it in. Now, A of T at the beginning, that's just what we're solving for, what we're trying to find. Technically, I'm going to write A of 6. We're not going to do anything with A of 6, but that's what we're finding. We're finding the amount or the balance after 6 years. So that's what I'm trying to find. Little a is 1,000 times, in parentheses, 1 plus R. What am I putting in for R? 0.05. Raised to the power of T, which is 6.
Where did the 1 come from? Why do you have to add the point of 5 to 1?
So this 1 right here technically represents 100%. So a problem starts at 100% because 100% of a given amount is that amount. And then that's why we're adding 5% to grow it. Or if we were decaying, we would subtract the amount. But that 1 basically represents 100%. Okay? Yes?
So on quizzes and tests, if we don't put the A of 6 in front, will we get points off?
No. Okay. Now, I see one step I can do here before I pick up my calculator. 1 plus 0.05? What's 1 plus 0.05? 1.05? So that's where I'm at, guys. And I absolutely cannot go any farther without my calculator. So this is where it's important to me that you are practicing with me today, right? Don't wait until the test to be like, how do I put this in the calculator? Because I'm going to know you haven't been doing the homework and you haven't been doing the review worksheet and stuff if you don't know how to put it in the calculator by test day. Not that I won't help you, but okay. I like to say Aunt Sally. What's Aunt Sally tell me to do here? We have to do these exponents, yes? So officially, the next part we're going to do is 1.05 to the 6th. But then I'm not even going to write that down because then the next part I'm going to do is times 1,000. So let me get my calculator on the screen here. I know we don't all have the same calculators, but we should all come up with the same answer. And if we don't, your job is to ask for help, whether it be from a neighbor, whether it be from me, but let's make sure we know how to get this in the calculator, right? Now, if I'm putting my exponent in first, I can do 1.05 raised to the power of 6. So 1.05. Do you know your exponent button? Mine is my arrow there on the left side. It's the caret raised to the 6th. So mine is this. If your exponent is different, it could be a y to the x or an x to the y button. Those are the other common ones you would see. Did you find yours? And then for 1.05 raised to the 6th, I'm going to hit equals. And I have that lovely number. I'm not even going to write that number down, though. Because what's the next thing I do? Multiply it by 1,000. So I can just hit times 1,000. Does your answer match my answer? If so, you know how to use the calculator. If not, let's figure out where you went astray. If you don't know where your exponent button is, let me help you figure, because everyone has one somehow, someplace, right? So, my calculator answer is 1340.095641. Be smart about this. And technically, it does go on, right? What kind of answer am I going to expect? What kind of answer is Math Excel going to expect? What are we working with here?
1344.
Because we're working with money, yes? This is paying interest on $1,000. So this is money. So this is $1,340.10 because we give 2 decimal places for money always, right? Unless it says to round to the nearest dollar, you always assume two decimal places. So 09, well, the 5 tells the 9 to go up to a 10. So $1,340.10. Did we get it? To me, this is not a difficult thing as long as you don't shy away from the calculator and whatnot. Okay, let's go ahead and do the next one. It'll just let us practice a little bit. And unfortunately, that'll have to be our cutoff point, which was not my original plan, but we'll go with it. Okay, suppose you invest $500 in a savings account that pays 3.5% annual interest. How much will be in the account after 5 years? Do you know enough to stay a step ahead of me here? You invest $500 in a savings account. 500 is initial value pays 3.5% annual interest. What is that?
Would that become 0.035?
Yes. Okay, so that is my percentage rate. When I move that decimal 3 left, you move it past the 3. I just said that wrong, didn't I? When you move the decimal 2 left, you move it past the 3 and past the 0. So it is 0.035. How much will be in the account after 5 years? So that means the T is 5. We invested money. It's paying us interest. So again, this is a growth example. Okay, same formula as above. A of T equals A times 1 plus R raised to the T power. And if some of you guys don't like this, we're going to be finding A of 5 because we're finding the amount after 5 years. Notice on the last one, did I ever do anything with that 6? No, that's what I was finding. This is just what I'm finding here. Little a, what's my initial value? 500. 1 plus R. 1 plus 0.035. Raised to the T. Raised to the 5th. So 500 times 1.035 to the 5th. Now, if you didn't try it out last time, you know you can enter this all on your calculator at once, yes?
Yes.
Okay, that honestly is my recommendation once you get comfortable with the calculator. In fact, did you know you could enter that all on your calculator right there? You could just write down the first line and enter that on the calculator.
I did though. Remember I first did it, I was going to do it all on the calculator, but I forgot the one that you had to do.
Okay, so then you're going to have to start over. Yeah.
I don't trust
Okay.
myself doing that.
Huh?
I don't trust myself doing that and not.
Okay, so if I do this, 500 times parentheses, I can say 1 plus 0.035 in parentheses raised to the 5th. Does your answer match my answer?
Right.
If not, figure out why, right? Don't just say, ugh, I stink at this stuff, I can't do it, I quit. No, you cannot say that. This is very doable. You just have to figure out where you made your mistake. So it's 593.843158. What's your smart answer you're going to give me? $593.84. Okay, guys. I had planned to get through the notes today. The 2-hour delay did not work in my favor. Do what you can in Math Excel. I do need to look at a little bit, at least maybe 2 more examples to make sure you know how to do everything in homework. So I will have to decide how I want to handle Monday and go from there. But definitely go ahead and start working on that homework, okay? But I will finish a couple examples on Monday.